Hey everybody, so I'm Mark Harmon and this is David Sparks. We are both STEM teachers at Ashland Middle School in Ashland, Kentucky. So like many schools around the state, really around the nation, our students were struggling with mathematics. I think from 2013 to the present, we only had like 45% of our students scoring proficient or distinguished on the K-Prep assessment. So we started doing some research into ways to help improve that. And with our STEM background, we started looking into computer science. So there's some of the studies, but there are dozens more that cover the same stuff. The more coding, the more computer science students are exposed to, the better they perform in mathematics. So we started using this curriculum. It's the Project Lead the Way curriculum, because one of the things that we noticed was the curriculum didn't really matter. I'll hit you. The curriculum didn't really matter. That it the results were based upon the connection between computational and algebraic thinking, and then through these computer science courses, we were actually able to give our students real-world examples that they could apply these somewhat abstract concepts. But I'll let David tell you some more about our program.
So what we did is we adopted the Project Lead the Way computer science middle school program. Since we're already a Project Lead the Way school, it made the most sense. And we have two different classes, innovators and makers and app creators. Mark teaches innovators and makers, and I teach app creators. They take two different approaches to computer science and programming. One of them is physical computing, and the other one is app-based, so you're actually learning to, develop software. And from there, we administer the Northwest Evaluation Association's Measures of Academic Progress, or MAP assessment, and then monitor each student for their mathematical performance. And then we compare the participating students' growth to non-participating student growth. So a bit about my App Creators class. It's an introductory CS class that covers all of the major computer science principles, all the way from basic algorithms to more abstract things like loops, lists, et cetera, et cetera. It focuses on the application of algorithmic thinking and learning to work as a team and work in a group. My students from the get-go in this class are taught, if you're a solo artist, this is not necessarily the class for you, because we want them to be able to learn to work in a group-oriented environment. So the emphasis is on collaboration and authentic projects. And it takes an approach where there is a central theme throughout each of the projects that they work on. And that central theme is from like a medical standpoint. So in one project, they may be working on an app that will give first responders information out in the field if they don't know something about a particular disease in case of natural disasters. Stuff like diseases that are typically associated with like crowding, because after a natural disaster, there may be lots of people that are crowded into a small space. So and things like that. And then another app is a simple game that they make where they have a white blood cell that's trying to combat the germ. And apps are alpha, beta, and final tested right there live in the classroom due to the software that we use called MIT App Inventor. And they can download that straight to a set of tablets that we have, and when they make changes to the code on their laptops that they're working on, the code automatically goes over to their tablets so they can see their changes in real time. And then stemming from that, we participated in Samsung's Solve for Tomorrow competition again this year. And one of the things for our project that was chosen, our project revolved around helping veterans. and it was called Benevets for the Brave. And what it was utilized for was to help veterans get to benefits and other things in a more timely fashion. Because going through this for them, not just veterans, but also spouses and stuff like that, it can be a very arduous chore. So we designed a website and a companion app that helped them be able to do that. And they were able to access those critical resources better. We were chosen as the state winner for Samsung Solve for Tomorrow this year, and we're able to secure $20,000 in technology for our school. And the app's main feature was it featured an SOS button that serves as a direct line to the Veterans Crisis Center. And that is App Creators, and I'm going to turn it back over to Mark.
Okay, so my class, I already teach in a STEM lab that's set up so students can fabricate physical devices. So mine focuses on actual hardware and software, which the bottom one down here is a project a student did in which they developed their own switch. And then this 3D printed object was printed from conductive filament. So as long as the object was sitting inside on those two copper strips, nothing happened. But then as soon as someone tried to remove the statue, it set off an alarm and notified them that somebody was messing with their stuff. The top one actually made a safe that had a password combination, which was pretty neat. So like we were talking earlier, we administered the map assessment. Round 1 and 2 went as planned. Round 3, our school administrators introduced a new ELA program, so they had to push our last map scores off. We just got that data back like in a couple days ago, which actually I think that number's a little off, but we're going to have to go back and analyze that. But our initial data showed slight growth, not enough that would definitively say whether or not it's improved student performance, but our students did perform about a half a point higher than non-participating students. But like it says, additional studying, additional looking at the data is needed.